Introducing the New Horizons spacecraft, the first of NASA's New Frontiers missions. This video was created by Molly Johnson, Adam Boldy, and Emma Schaefer for 16853 Advanced Satellite Engineering. New Horizons is a collaborative effort, primarily between the Southwest Research Institute, the Johns Hopkins Applied Physics Laboratory, and NASA. The mission was proposed by principal investigator Alan Stern and accepted by NASA in 2001. The mission had many objectives outlined by NASA. In summary, New Horizons aimed to reconnoiter Pluto, fly by objects in the Kuiper Belt, collect science at Jupiter during a Jupiter flyby, and collect deep space data during cruise. The total cost of the primary mission was $700 million. The New Horizons spacecraft launched on an Atlas V 551 on January 19, 2006. The launch vehicle stages brought New Horizons into a solar escape trajectory, reaching speeds of 16.2 kilometers per second. After launch, New Horizons took only 13 months to reach Jupiter, where it performed a gravity-assisted maneuver. This allowed the spacecraft to reach Pluto 3 years in advance. During the Jupiter flyby on February 28, 2007, New Horizons took data samples of the gas giant before starting its 8-year journey to Pluto. During these long periods of cruise, the spacecraft puts itself into hibernation mode. On July 14, 2015, New Horizons reached Pluto, where it took data of the dwarf planet and nearby moons for 8 months. After this, NASA extended the mission, so New Horizons was able to explore objects in the Kuiper Belt, including the infamous snowman asteroid, Arrokoth. As of 2023, New Horizons continues traveling and is expected to function until 2050. Let's talk about the spacecraft configuration. The spacecraft structural foundation is a central aluminum cylinder, which is attached to the propellant tank and bulkhead decks. The total wet mass of the spacecraft was 478 kilograms. New Horizons has 7 science payloads on board. Ralph and Lori are the 2 imaging payloads, with Ralph having multiple channels, a wider field of view, but lower resolution than Lori. The beautiful images of Pluto commonly seen on the internet are a data product of Ralph. Alice is an ultraviolet imaging spectrometer which aims to characterize Pluto's atmospheric composition. Rex is a device that uses radio waves to characterize the atmosphere at Pluto. SWAP and PEPSI are 2 energetic particle detectors, SWAP computing particle flux while PEPSI does characterization. Finally, the Student Dust Counter, a late addition to the mission, characterizes dust particulates along the entire trajectory from Earth to Pluto and beyond. Alice, Ralph, and Rex are the primary instruments aiming to do the required Group 1 science, while SWAP, PEPSI, Lori, and the Student Dust Counter are secondary instruments that additionally fulfill Groups 2 and 3. The spacecraft has 1 large high-gain antenna used for downlinking science data. 1 medium-gain antenna is used during cruise or emergencies. 2 low-gain antennas were used during early operations when the spacecraft was within 1 AU of Earth. At Jupiter, the spacecraft could only downlink 38 kilobits per second. At Pluto, it could only downlink 1 kilobit per second. Key components of the power subsystem include the General Purpose Heat Source RTG, the Shunt Regulator Unit, the Power Distribution Unit, and the Propulsion Diode Box. The RTG efficiently converts the heat generated by plutonium radioactive decay into electricity. The SRU maintains the bus voltage at 30 volts. The shunts are N+1 redundant, able to dissipate 19.5 watts each. At peak, the spacecraft consumes 240 watts of power. A main design of the thermal system is housing many subsystems into a structure that is similar to a thermos bottle, ensuring most components are connected to an overall spacecraft bus temperature. The thermal system has components such as multi-layer insulation, louvers, heaters, and radiators to maintain thermal balance. The propulsion system consists of 12 attitude control 0.8 Newton thrusters, 4 primary 4.4 Newton thrusters, a hydrazine propellant tank, and associated control valves. The chosen pressurant is helium. Each thruster has a primary and secondary heater. Since the spacecraft is in deep space, it uses its 12 ACS thrusters to orient itself. There are dual redundant star trackers, IMUs, and sun sensors that provide the spacecraft with attitude knowledge. As of 2023, New Horizons has provided us with a plethora of data. We've received images and atmospheric data from Jupiter, Pluto, Pluto's moons, and several Kuiper Belt objects. In addition, New Horizons took solar wind and dust measurements in deep space. In summary, New Horizons has been a largely successful mission that is still ongoing to this day. The New Horizons spacecraft stands as a testament to human curiosity, scientific innovation, and the spirit of exploration. This concludes our video on New Horizons. Thank you for watching.